And the first proof I'm going to show you is how 2 equals 1. So we're going to follow this algebraic proof of how we get to 2 equals 1.
These students are looking at mathematical proofs that each contain a logical flaw. For each proof, the students have to identify the flaw.
So have a think, can you spot where there could be a mathematical flaw? So the very first task that we looked at was using algebra to prove 2 equals 1. And initially the students couldn't spot where the mathematical flaw was, but with a little bit of probing, they were able to identify that there was a division by 0 in one of the lines of the proof. A and B are 2 non-zero numbers such that A equals B.
Oh, A equals B, so it's the same number, so A minus B is going to be 0, and you can't divide by 0.
Fantastic. So we talked about why we can't divide by 0, and that was the fundamental flaw in the argument. I then gave the students 4 proofs to look at, and they all contained a mathematical flaw. I think they were quite intrigued when they were first given the task. They got stuck into it. Initially, they were struggling to find the flaws in all the proofs.
If you squared that, it'd be 100p squared, right?
So how should that how that line?
So you've got to square that as well, don't you? If you're going to square both sides.
Because it's only written as 0.1 rather than 0.10. No, but then that's different. It's because it's 10p rather than...
I was moving around the classroom, visiting the different tables, listening to their discussions, finding out what they'd discovered, finding out what line of thinking they were going down. I started by just asking them if they'd spotted anything that they thought was unusual, that they felt uncomfortable with, and asked them to explain why they thought that was. Often they came up with some very good mathematical ideas on why the thing they had spotted was a flaw. I tried not to give them answers, but tried to point them in the direction of a part of mathematics they needed to be thinking about that would possibly help them figure out where the flaws were. From there, they were able to then think a bit more for themselves and work out what the flaw was in the problem. Yeah, that's fine, isn't it? 10p does equal 0.1 pounds. It's a straightforward conversion. Where does it look a bit strange? Where do you think? Where's your gut feeling? The one with the pence. Initially, they were thinking, can you write 10p as 0.1 pounds? And we agreed that that was fine. It was just a straight conversion. And then when they looked at the p squared, they realised that you can't square a pence.
I still think it's like... Maybe it's to do with squaring this though, because it's only written as 0.1 rather than 0.10.
On the one with the square root, they arrived at the fact that there was a positive and negative square root when you square root a number. And initially they didn't spot that. And I think sometimes students forget when they're doing a mathematical step what all the different outcomes and possibilities are.
So it's just all about the square root is into the plus or minus basically.
Because that's what you got, minus 1.5.
I think they quite enjoyed doing the task because it was quite different to anything they've done before. I hope it will help them just think about what's going on, think about the mathematical arguments that have been given to them, rather than just learn facts and be told what to do and be taught processes. Because I think some of them are a little bit afraid of exploring maths for themselves. They like to be given a proof and shown how to do things all the time.